In my first video, I shared who I am and how I became a professional engineer. In this video, I want to answer a question I get all the time. What does a professional engineer actually do, and why does it matter for building systems? It matters because the answer affects safety, comfort, and operational costs more than most people realize. If you work with building systems, mechanical, electrical, plumbing, or controls, this channel is for you. Welcome to Building Science Analytics. Today, the word engineer gets used for a lot of different roles. We hear terms like software engineer, controls engineer, service engineer, and those are all important jobs, but a professional engineer, or PE, is something very specific. Just like a CPA license defines an accountant or a bar license defines an attorney, a professional engineering license tells the public that you've reached a verified level of competence in engineering. It shows that you've met rigorous standards, that you take responsibility for your work, and that you're committed to practicing engineering the right way. Most importantly, a PE license gives you the legal authority to offer engineering services directly to the public. Those two letters after your name aren't just a credential. They signify legal responsibility, professional accountability, and public trust. A professional engineer is legally responsible to prioritize public welfare, hold high ethical standards, and serve humanity through integrity and competence with a commitment to honesty, skill, and placing the public good above personal gain. That legal responsibility changes how you think about design decisions. To become a professional engineer, you have to earn an accredited engineering degree, pass the fundamentals of engineering exam, gain years of supervised experience, and then pass the professional engineering exam. Once licensed, a PE can seal construction documents, and that seal means accountability. Here's my embossing seal, ink seal, digital seal. These are the most powerful tools I own. They represent the definition of accountability. I got this definition from a quick Google search. Accountability: the obligation to provide a detailed explanation and accept the consequences for one's actions, decisions, and their outcomes, often involving owning mistakes and fulfilling commitments to foster trust and ownership. Once these seals are used and it's applied to a document, you now own whatever is on the paper, whether it's good or bad. If something goes wrong, a professional engineer doesn't just explain what happened, they're responsible for the decision. That responsibility affects how conservative, thoughtful, and intentional design choices need to be. In real buildings, a professional engineer isn't just selecting equipment or drawing ductwork, electrical circuits, and water lines. We're asking questions like, how many people will occupy this building? What are the occupied hours? How will the building be used? Where is the building located? What is the building's orientation to north? How many windows are on the south side of the building? What happens if this system fails? How will the system be operated and maintained? How easy is it to access the equipment for maintenance? Will this system be energy efficient over the life of the building? Do these systems meet code? These questions matter most for systems like HVAC and building automation, where small decisions can quietly cost owners thousands of dollars over time. Good engineering doesn't just work on day one. It works 5, 10, 15 years later. This channel exists because there's often a disconnect between how buildings are designed, how they're controlled, and how they're actually operated. Here on Building Science Analytics, I'm going to break down HVAC systems, building automation, energy strategies, and common mistakes I see in real projects. No sales pitch, no fluff, just practical engineering insight from real buildings. If you work with buildings or want to understand them better, consider subscribing. Better buildings come from better understanding. This is Building Science Analytics. I'll see you in the next video.